Okay, let's check out some cool exercises with planes in triple projection and in axonometric. So first things first, let's see how a normal plane would look like in a triple projection. So again, a normal plane can be extended to infinity, right, when you're drawing it. So the way we will represent it is not by its projections, its planar frontal and side projections, but through the cuts that you get from extending the plane, okay? If you extend it, you cut the frontal view, cut the planar view, cut the side view, like so, okay? Let's see how this would look in a axo, because this is obviously going to make more sense. We talked about simple planes, not simple, but particular planes. Let's talk about a random plane. Okay, just copying the dimensions off of your sheet, just like that. That's going to help you as well. Okay, good. Let's connect everything up, just like so. And this creates our plane. Okay, it looks like a triangle. Okay, and you can imagine it's a random plane. It doesn't really matter what angle it creates. Okay, let's connect everything up. Okay, let's add the axes. Right. Okay, let's thicken the plane as well, because we will need that clarity. Okay, and moving on, we will start a couple of just simple exercises, basically getting one of these weird planes, weird random planes rather, and just think, how can we add an edge that's sitting on, or a segment that's sitting on this plane, that's included in this plane, right? And how did I go about that? You see the projection of the this is an important one then. You see it's perpendicular, right? You see that the planar view is the planar projection of that line is perpendicular on our plane, right? On the so the planar projection of the line, bear with me just a bit, is perpendicular on the it's interesting. It's perpendicular on the cut of the plane on the horizontal projection plane. Okay, that means this edge is actually the maximum incline edge, so it's called. Okay, so if we are going to draw this in an axo, you'll see that it's going to create an angle, right? That's going to be the maximum incline of our random plane. Okay, it's very important. You see this when we are constructing basically a lot of cool stuff around roofing. Okay, because there we are dealing only with the maximum incline. Okay, because we need to find those slopes. Obviously it gets a lot more complex than this, but or rather the principle is the same. The context gets a bit more complex when you're actually doing it, but that's beyond our point. For now, let's just draw that perpendicular line. Don't forget the catch is that always the axonometric is going to look a bit deformed, just because it's an axo. Okay, and this is going to be our segment, right, which is the maximum incline edge. Next up, we will be drawing a couple of again particular edges that are sitting on our plane. Maybe some horizontal ones, maybe some frontal ones. I don't know if we are going to get any perpendicular ones. Okay, I think we are going to get the parallel ones. Okay, so parallel to the horizontal plane, which is going to be a horizontal edge or segment, frontal edges which are parallel to the frontal plane. Okay, profile lines, let me just call them lines or segments. Profile lines which are going to be parallel to the profile plane and so on, to the side plane and so on. Okay, yeah, so this is our perpendicular maximum incline edge, and these are its projections. And that's it. This is the short little exercise. Next, We're not stopping here. The thing is, you know, it's different. Okay, I want you to really zoom in and think about this stuff. You know, the maximum incline could also be a tangency, okay, because we do deal with that, right? Yeah, it's just different. If we're looking at the 95-5 approach, I'd really stress that the 5% which is important in this lesson is you really focusing on understanding how to see these planes in 3D, understanding that you know, extending a plane and the cuts that you get from extending the plane. Yeah, that's what matters. Okay, that's what's going to generate a. That's what's going to generate. You know, your further understanding of the volume. Okay, this is a random edge, which is sitting on our plane. Okay, so it's not forming any angle. It's just, the thing is that its proportions are basically, its projections, sorry, are basically sitting on the you know, cuts of the plane. Okay, so simple as that. If our largest inclined line, you just had to draw a perpendicular line in the planar projection, then just yeah, raise the frontal view. Here you can just correlate the frontal view and planar view, and you know, the side view is going to work itself out. And this is going to be a random edge or segment. I call it an edge because it's a segment or line that's included in our plane. Okay, let me just draw that. And yeah, after we are done with that, I'll thicken the projections and we are good to go. One thing you might want to focus on is the clarity of graphics. As you see, the way I'm drawing is almost as if it's printed, okay? Don't press on that pencil too much. Always remember to sharpen it, right? I edited out the parts where I'm stopping and sharpening the pencil. So the whole lesson looks flawless, okay? So it's easiest for you to understand it. That's a secret. I'll tell you behind the scenes secret. I've increased the speed at 140% because I just don't want you to waste time, you know, watching me draw. Okay, so it's going to take a bit more than yeah, this lesson is 20 minutes. It's going to take a bit more than 20 minutes to get this right. Okay, moving on. So let's draw a random plane. Okay, don't forget that the 45-degree thingy where you move the OY dimensions to the OY second dimensions. And this is going to be a frontal edge that's sitting on our plane. Imagine that. Okay? The thing is, it's sitting on our plane because obviously the planar projection is parallel to the plane cut through the horizontal plane of projection. Right? So the edge or segment's horizontal projection, okay, is parallel to the cut of our plane to the horizontal plane of projection. Okay, so we are going to basically get this kind of thing. Okay, so it's included. You'll see how it looks like in the axonometric, in the 3D. Okay. Obviously, we've got let's say. After we are done with this, we can draw a frontal line as well, which is included. Okay, that's going to work as well. And yeah, multiple frontal lines, an infinity of frontal lines. Okay, because all these things, you know, they yeah, they can go to infinity. But again, we are not going in that part of the understanding. We are just going to you know, express this concept all the way through. Okay, have a horizontal segment included in a random plane. Okay, so I'm just drawing the horizontal projections right now and connecting everything up, just like so, like so. Okay. Up, mistake. As you see, right, we need to draw those segments horizontal. Okay, so take the heights, just bring them up like so, right? Those are our segments. Okay. let's connect everything up. Let's thicken the edges. Okay. Yeah, maybe add some points for the projections as well. Okay, not that much of a big deal. Points are essential when they actually are needed. For instance, tangency points, or stuff like that. Where you need to calculate a point which is in a larger scheme of descriptive geometry, right? Here it's just about graphics. Okay. Maybe draw the projections as well. Okay, and draw those points as well. As you can see, we already did a couple of exercises, and hopefully by now you got a bit more used to the mindset behind these planes. Okay, to how a plane looks, how to add some segments that are sitting on our plane, and so on. Right, let me just draw another plane. Right, and these are going to be frontal edges. Okay, I'm drawing parallels right now by sliding a triangle onto another triangle. And then, yeah. Side view. And if we connect everything up, then we will get our volume. Yeah. Let's get those edges looking crisp. Right. Okay, let's add the necessary bit of line graphics. So some contour lines. Yeah. This is interesting. This is exactly what we are looking for. Right, don't forget these are frontal edges, so they look like simple lines, simple parallel lines in the planar and the side view. Right, let's name them. Okay, if we name them, then it's again more familiar. You want them. Basically, this descriptive geometry, you don't want it to just be a thing. You need to, they call it, internalize it, make it a part of the way you see things. Okay, right, let's copy all those dimensions and add them in the axo. It's basically a repetitive task, but why not? Let's finish this. Seeing things all the way through is actually a skill set in itself. Okay, so let's add everything else and let's draw. Okay. Don't forget these are frontal. So the inclined projection is the one on the frontal plane. The other projections are just simple. Right, let's go. Point by point we will figure this out. Yep, some heights, and then let's connect these segments, name them, and that's our exercise. Right. Let's see. Okay, this is our plane. Those are the parallel lines, the frontal lines. Okay, let me just erase that a little bit there. Yeah. Let me just name these. And add the projections as well. Some projections overlap. So the planar projection for A is going to overlap. Okay, that's fine. I didn't bother to thicken the projections again or color them because that would make the drawing a bit too complex. Okay, it would take things out of context. Okay, let's see a couple more exercises. So how would two planes that are parallel, how would that look like? Okay, well, if they're parallel, that means that their cuts through the reference system are parallel as well. So you got your answer right there. Okay. Okay, there we go. We've got our plans. Let me just add a bit of information. And then we can see in 3D how they look like. P and R, the two planes, which are parallel. Okay, let me just thicken them. Okay. Let's go for the axonometric as well. Right. We'll probably look at generating a plane through two intersecting lines and maybe two intersecting planes as well to see how that works. Yeah, there's multiple possibilities here. Okay, let's go. Very good. Okay, these are our planes. And let's just thicken them. Thicken the axes. And that's it, yeah. Simple exercise, but again, I want you to understand the logic behind it. Okay, not just draw some lines on a piece of paper, but understand the logic behind it. Right. Let's see. Let's see what else we can go for. Yeah, so by now you've probably got used to the plans, the thinking behind, two plans. Right, so we are going to get two intersecting edges, and my guess is that we can actually go on and, or rather no, make this like two intersecting planes. Alright, there's that old assignment, age-old question, how to generate a plane. You can generate a plane by two parallel lines, two intersecting lines, and three points. Okay, and at a certain interval of time, we'll be discussing that. Okay, so what did I draw now? I drew two intersecting planes. Okay, so they intersect. So when they intersect, they generate that edge. Okay, that edge is what we are going to thicken. Okay. So let me just see how this could work. That's one plane. There should be another plane as well. Probably use colors to make this look a bit more interesting. So that should be the part which is popping out, so to speak. Okay. So I don't think we need all three views to intersect. Okay, I think it's enough to have a planar view and the side and the frontal view intersect. Those generate the edge. And obviously, because of the way you see the geometry, okay, it's going to be obvious that, how the cut looks like. We'll see. We'll problem solve here, okay? If it's not clear from the triple projection, it's definitely going to be clear from the axonometric. Right, that's why we are measuring everything up and drawing everything else again. Right? just like so. Right, getting those dimensions. Okay, and this is going to be our plane. Right, you can see it's intersecting and it's generating that segment. Okay. Yeah, I think the side view is off. Okay, it needs to look a bit different. Hopefully I correct that, right? The gist of it is that, yeah, the side view is off. Although they won't be obvious, they won't be obviously intersecting in the side view, it still needs to be correct. Okay, no excuses. So basically a second needs to connect to the left-hand side point, right, in our side view. Okay, let's see. So that's going to be our edge. Okay, it makes sense, right? That's going to be the tip, which is popping out. Maybe thicken that a bit. All right. Okay, so the intersection is going to be obvious in the planar view, in the frontal view, and not as obvious in the side view. Okay. And yeah. Yeah, this is our planes intersecting. Okay, so these are the basic exercises for 2D descriptive geometry. At one point we will be studying more advanced technical drawing for 2D geometry, but this is good enough for now. Okay, so hopefully you understood everything here. And again, focus on really understanding what you're drawing and not just drawing lines. Okay? Good. Really good.